This next lesson is on angle measurement and segment length. Now you may want to take out your note sheet that says notes of arcs and angles. It has all of your formulas on it to help you identify what theorem you need to use in order to solve the problem. So for problem number 1, I have two arcs and I'm looking for the angle. So notice that this angle is what makes this arc measurement of 1/16. So my theorem says that I can add these two arcs together, divide by 2 to get the measure of x. So x is equal to 1/16 plus 70 divided by 2. So 1/16 plus 70 divided by 2 gives me a measure of 93 degrees. Now problem number 2 is similar, but notice that my angle measurement that I'm looking for does not correspond to these two arcs. So what I'm going to do is I'm going to find the measure of this angle. Then, since I know that this is on a straight angle, I can then subtract from 180 to find the measure of x. So I'm going to say 20 plus 28 divided by 2. So 20 plus 28 is 48. 48 divided by 2 is 24. So the measure of my angle here is 24. That's not the measure of x. You can call that y if you want to. So now in order to find x, I'm going to say 180 minus 24, since that is those two pieces are on that straight angle. So 180 minus 24 gives me a value of 156. Now for problem number 4, I have a different type problem. I have a secant line and they meet outside of my circle. For 1 and 2, both of those angles were inside the circle. Number 4, my angle is outside my circle. So in order to solve for that, I have to use a different theorem. So my theorem for 4, I have to take these two pieces here and subtract them. But what I have to remember is I have to subtract the larger angle first. So x degrees is equal to 1/2 of the larger angle minus the smaller angle. Arc. Larger arc minus the smaller arc. So 90 minus 20 divided by 2, x is equal to 35 degrees. Number 5 is a similar type problem. However, notice I don't have the measure for this arc here. So in order to find the measure of that arc, I'm going to say 360 minus 240. The whole circle has 360 degrees. I know this piece is 240, so I'm going to subtract that so I can find the measure of my missing arc there. It gives me a total of 120. So now I can use the same theorem I used in number 4 to find the measure of the angle. So in order to do that, x degrees is going to be equal to 1/2 of 240 minus 120. So 240 minus 120 divided by 2, x is equal to 60 degrees. Now for the rest of the problems here, they're using those same theorems, they just gave you different information. Now on the back side, here we have 1, 2, 3 other theorems that we talked about in section 4. So notice in figure number 11, all of my pieces are inside the circle, and I have two lines or two chords that intersect. So in order to solve for the missing piece here of z, these two pieces that are on the same chord get multiplied, these two pieces that are on the same chord get multiplied so that I can solve for z. So 3 times 8 is equal to 4 times z. So that's going to give me 24 is equal to 4z. Divide both sides by 4. Z is equal to 6. So 6 is the measure of this piece of my chord here. Now in problem 12, you have a different type problem. Notice that they meet outside the circle. So this time, since I have two pieces, they're not all inside the circle, I have to use a different theorem. So I have to say 7 plus 5 times the piece that's outside the circle is equal to y plus 4 times the piece that's outside the circle. So every time that you work a problem similar to this, the piece that's outside the circle is what the problem is being multiplied by. So 7 plus 5 times 5 gives me 60 is equal to 4y plus 16. So I'm going to subtract 16 from both sides. Gives me 44 is equal to 4y. Divide both sides by 4. Y is equal to 11. Now, problem number 14 is also a different type problem because notice I have a tangent piece and a secant. So when that's the case, the tangent piece becomes squared and it's on a side by itself is equal to, same concept that I used a minute ago. So 21 plus y times the piece that's on the outside. So I get 100 is equal to 21y plus y squared. So now in order to solve, notice that I have two pieces, two y values, and I have one that's squared. So I'm going to move everything to one side and solve from there. So y squared plus 21y minus 100 because I had to move the 100 over so that everybody was on the same side. So I can do one of two things. I can attempt to factor, or I can graph my problem, put this in my calculator and graph it to see what my solutions are going to be. So I can either graph this or I can solve by factoring. I went ahead and factored the problem. You can put this in your calculator and graph it to see where it crosses the x-axis. Also going to give you the same solutions that I'm getting ready to find here. So by working it out this way, I get y equals a negative 25 and y equals a positive 4. Now the length of my line cannot be negative, so therefore this is not my solution. So y equals to 4 is my solution for number 14. So notice that 15 is another similar type problem. It's a little bit easier because my y portion is not outside the circle. So for 15, I'm going to have 8 squared is equal to z plus 4. Now the reason that I'm adding z and 4 together is because they're on the same they're on the same line. So z plus 4, and then it gets multiplied by 4 because 4 is on the outside. So 64 is equal to 4z plus 16. So 64 minus 16, and then I'm dividing that value by 4. Z is equal to 12. So it will be helpful for you if you get your sheet out that I gave you that says notes of arcs and angles, or if you look through your note sheet and find your theorems, match up the picture to your theorems in order to help you solve the problems for practice.